The definition of the power rule says that if we have x to the nth power, then its derivative is going to be n times x to the n minus 1. So what does that mean? If we have x to the 6th, and we're asked to find the derivative, then according to the power rule, we have to bring this power down. So we get 6x, and then we minus 1 from the power. So we get 5. 6x to the 5th is the derivative, and that's all we had to do. So let's say we are asked to find the derivative of x to the 98th power. So once again, we're going to bring that 98 down. So we're going to get 98 times x to the 98 minus 1, which is 97th power. And this is the derivative. What about the derivative of x? So the derivative of x, we can imagine that as having a power of 1. So its derivative is just going to be, we're going to bring that 1 down. So it's going to be 1 times x to the 1 minus 1 power, which is 0. X to the 0th is 1. So the answer is just 1 times 1, which is 1. So the power rule makes it a lot easier to take derivatives of these kind of x's to these powers. And we don't have to use that long definition of a derivative. And then a note to make is that the power rule works for all powers. So it works if we have a negative power, if we have a positive power, and even if we have a fractional power. So keeping that in mind, let's practice a few more. So let's say we are asked to find the derivative of f of x is equal to 1 over x squared. So here, this is kind of hard to see, but if we rewrite this and we say that f of x is equal to x to the negative 2nd power, then we can visualize using the power rule a lot better. So all we did is that we restated this fraction as x to the negative 2nd power, because if it's down here in the denominator, it's going to be negative if we bring it up. We rewrote this function, so now we're going to apply the power rule. So we're going to bring that power down. So we get f prime of x is equal to negative 2x, and then negative 2 minus 1, which is negative 3. And then we can just rewrite this as being negative 2 over x to the 3rd, because we have a negative 3rd power here, and this is our derivative. So what if we're asked to find the derivative of f of x is equal to the square root of x? So similar to what we did up here, we're going to rewrite this function in terms of a power. So we're going to rewrite it as x to the 1/2. And then the derivative, f prime of x, is going to equal to 1/2 to the 1/2 minus 1. So we're going to say minus 2 over 2, which is equal to 1/2 times x to the negative 1 over 2. And then we can write it in its more natural form, and we're going to say that this is equal to 1 over 2 times the square root of x, because this is saying that we have a square root that wants to be in the denominator. So this is the derivative. Okay, let's look at another one that's a little bit trickier. So let's say we have f of x equaling to the cube root of x squared. And we want to find a derivative. So to find a derivative, we're going to rewrite this as x to the 2/3. And then the derivative is going to be a lot easier. We're going to use the power rule, bring the power down, -1, so we're going to minus 3/3, and we're going to get -1/3. And then we can rewrite this derivative a little bit better. We're going to say that this is equal to 2/3 times the cube root of x. And this is the derivative. And then things can get a little bit harder. Let's just say we have a polynomial. And we have x squared plus x plus 1. And we want to find a derivative. Well, there's another rule in calculus that says that the derivative of a polynomial is just going to equal to the derivative of each term. So that's going to equal to the derivative of x squared plus the derivative of x plus the derivative of 1. So using the power rule, we're going to get 2x plus 1 is going to be the derivative of this polynomial. So just using this simple rule that the derivative of a polynomial is equal to the derivative of each individual term added together, then we get this. The derivative of x to the second is 2x plus the derivative of x is 1 plus the derivative of any constant is just 0. We have a 1 here, so it's just 0. And then let's try one last one that's a little bit harder. So this is going to be a polynomial. So the derivative of 2x to the 7th minus 5x to the 3rd plus 11x squared minus 19x plus 24. So using the rule we just used up here, we're going to say that the derivative is going to equal to the derivative of each individual term. So the first one, we have 2x to the 7th. We're going to bring this power down. We're going to keep this existing coefficient. We're going to bring this one down. So we're going to get 2 times 7. So that's going to be 14. X to the 7 minus 1. So 6. Minus. So similarly, we're going to bring this power down, but we're going to keep this 5. So we're going to get 5 times 3, which is 15. X to the 3 minus 1, so 2. Plus, once again, we're going to bring this power down. So we're going to get 22x. 2 times 11 is 22. 2 minus 1 is just 1. And we have a minus 19x. We can bring that 1 down. We're going to get minus 19. X to the first minus 1 is x to the 0th, which is just 1. So we get a plain 19. And then finally, we have this constant. And we know that the derivative of any constant is just 0, so we don't even have to bother writing that down. So our final answer is this.